For more than a decade now, if you were talking about AI, you were pretty much talking about one language, Python. But things are starting to change. A revolution is kind of brewing under the surface. The very language that built today's AI is now facing a new generation of challengers built for speed, safety, and massive scale. Let's dive in.
And that's really the big question we're digging into here. Python is the absolute bedrock of modern AI. Giants like TensorFlow and PyTorch, all built on it. So what gives? Why is the world of AI all of a sudden looking beyond its undisputed king? Okay, so before we jump into the future, we've got to understand the present. And for the last decade, we have all been living in the age of Python. I mean, Python didn't just show up to the AI party, it basically threw the party. Its simplicity was a total game changer, making it the go-to for pretty much everyone, from researchers in a university lab to the top engineers at the biggest tech companies in the world.
Yeah, this chart pretty much tells the whole story, doesn't it? The numbers don't lie. When it comes to AI and machine learning, Python isn't just in the lead, it's practically the whole game. That dominance is just staggering. So what was its secret sauce?
Well, the reasons everyone fell in love with Python are actually pretty simple, but so powerful. First, its syntax is so clean and readable, it feels like you're writing in plain English. That just opened the doors for millions of people. And with all those people came this incredible ecosystem of libraries. NumPy for number crunching, TensorFlow, and PyTorch for deep learning. It just became the ultimate flexible tool for the job.
But here's the thing. As AI models have gotten bigger, like way bigger, the very things that made Python so great are starting to show their limits. We're starting to see a few cracks in the king's crown.
This really shows you the two sides of the Python coin. See, that easy, flexible nature comes with a price tag: speed. Python is an interpreted language, which means it kind of thinks on the fly. That's awesome for writing code quickly, but it's not so great for raw performance. Plus, it just wasn't built for the kind of massive parallel processing, running thousands of calculations all at once, that today's giant AI models demand.
And this right here? This is the heart of the problem. We're now training AI models with trillions of parameters. We're not talking about little lab experiments anymore. These are massive, industrial-strength systems. And at that scale, Python's performance issues aren't just a minor headache. They can be a serious roadblock.
So this urgent need for more performance has kicked the door wide open for a new generation of programming languages. Each one is tailor-made to solve the exact problems Python is running into. So let's meet the contenders.
Okay, first up in the ring, Julia. The whole idea behind Julia is simple. Why can't we have it all? It aims to give you that friendly, interactive feel of Python, but with the lightning-fast speed of a low-level language like C.
Julia was literally designed for this kind of heavy-duty scientific and numerical work. It's built to run your code across a ton of processors at once, which is perfect for modern AI. It pulls this off with something called a just-in-time compiler, which basically gives you the interactive feel of Python, but with run speeds that get incredibly close to C, the best of both worlds.
All right, next up, we've got Rust. Now, if Julia is all about being fast and easy, Rust is all about being fast and safe. This is a language that is completely obsessed with building systems that aren't just fast, but unbelievably robust and reliable. Rust's superpower is this amazing thing called the borrow checker. Think of it like a super strict proofreader that catches whole categories of bugs before your code even runs. This prevents tons of common crashes. It lets developers write really complex, parallel code with total confidence. They call it fearless concurrency. And when you're building the mission-critical backbone for an AI system, that kind of reliability is a total game changer.
And then there's Mojo, and this one has a really fascinating approach. Instead of trying to kick Python out, Mojo wants to be its super-powered upgrade. It's designed as a superset of Python. What does that mean? It means all your existing Python code should just work. No rewrites needed. Honestly, Mojo's strategy is kind of genius. It lets developers stick with the Python syntax they already know and love, but it hands them new tools to squeeze every last drop of performance out of their hardware, from multi-core CPUs to powerful GPUs. It's offering an upgrade path, not a total replacement.
Okay, so we've met the players. How do they actually stack up against each other and against the reigning champ? Let's go to the tail of the tape.
All right, this table really breaks it down nicely. As you can see, Python is still the undisputed champ of being easy to learn. It's perfect for whipping up quick prototypes. Julia steps things up with excellent performance, but the learning curve is a bit steeper, making it great for heavy-duty scientific work.
And then there's Rust, which gives you top-tier performance and safety, but it's the toughest one to master, perfect for that rock-solid infrastructure that absolutely cannot fail. And this is the key takeaway, right? There is no single best language. It's all about picking the right tool for the specific job you're trying to do.
So where does that leave us?
Well, it brings us to what I think is the most important idea in all of this. The future of AI programming isn't some winner-take-all fight to the death.
The future is what we call polyglot. It's a fancy word that just means developers are going to use lots of different languages together. They'll keep using Python for fast experiments and exploring data, but when they hit a performance bottleneck, they might rewrite that one specific piece in Rust or use Julia for a really intense simulation.
So if you're a developer or just interested in this space, what do? Well, the path forward is actually pretty clear. First, figure out where your code is slowing you down. Where are the bottlenecks? Second, match that problem to the language that's best at solving it. And finally, just experiment. These new languages are growing fast, and the best way to learn is to jump into their communities and start building.
You see, in the end, this isn't really a battle for a throne. It's an evolution of the entire toolkit we use to build the future. By blending the ease of Python with the raw power of languages like Julia, Rust, and Mojo, the real winner here is innovation itself. So the question we should be asking isn't which language will win. The real question is, what incredible new frontiers can we unlock when we use them all?